Alright, let's look at number 1. Graph y equals x minus 4. This is in slope-intercept form, so there's really, we could just use the y-intercept and the slope of 1 and graph this. That would be the quickest way. Most graphs, as long as they're not too terribly complicated, you could also make a table pretty quick and graph it that way, and that's usually the easiest way. So let me graph this by making a table. And remember, when you make a table, you come up with the x values. So I'm going to use -2, -1, 0, 1, and 2. And I'm going to take and I'm going to plug -2 in for x right here. Alright, and when I do, if I plug a -2 in, that'll be -2 minus 4. And -2 minus 4 is -6. So I put -6 right beside the -2. So that's an ordered pair. We have an ordered pair of -2, -6. Now plug in a -1. So I have -1 minus 4. That's -5. Plug in a 0. 0 minus 4 is -4. Plug in a 1. 1 minus 4 is -3. And plug in a 2. 2 minus 4 is -2. Alright. So now let's sketch this real quick. Alright, so we want to use these 5 ordered pairs. -2, -6, -1, -5, 0, -4, 1, -3, and 2, -2. So now connect all the points. Alright, and you have your graph. Now you could extend this if you wanted to. Just keep going and going and going. You could see that my x-intercept is going to be x equals 4. So that may help you a little bit when looking for the graph. There's really only one choice that it could be though, and that is A. Alright, let's look at number 2. Use the graph to determine the x and y intercepts. So number 2, really you just look at the graph. There's not really any magic going on. You look at the graph and look at the places that your graph crosses the x-axis and the y-axis. So I'm just going to kind of give a rough sketch here of what it looks like. Very rough. But kind of looks like this. It's a straight line, and you can see that it crosses the x-axis at -1 and crosses the y-axis at +5. So that means your x-intercept is -1. That can also be written as the point -1, 0. And your y-intercept is +5. That can also be written as 0, 5. Alright, so that's what we're looking for. We're looking for an x-intercept of -1 and a y-intercept of +5. So that's B, as in beta. Alright. Number 3. Add or subtract as indicated and write the result in standard form. So we have 2 complex numbers, And the way that you write complex numbers, you write the real part, then plus or minus, whatever you have, and then the imaginary part. Alright. As far as adding these together, you pretty much just add these together like you would if this was if the I values were just X values. You just add like terms. So add the 3 and the 2 together and you get 5. And then negative 9i plus 5i, that's going to be negative 4i. Alright, so number 3 is 5 minus 4i. That's in standard form. That's A. Number 4, 3i times negative 6i plus 3. Alright, so what does that mean? The directions say find the product and write the result in standard form. If you have something on the outside of parentheses, that means multiply. So we're going to take and we're going to multiply everything inside the parentheses times 3i. So that's going to give us negative 18i squared, right? 3i times negative 6i is negative 18i squared. And then 3i times 3, that's a positive 9i. Alright, and so where we have an I squared, remember with complex numbers you plug in a negative 1. So this is going to be negative 18 times negative 1, which gives you a positive 18, then plus 9i. So number 4 is D. Number 5, 3 plus 3i times 5 minus 6i. Alright, so here I'm multiplying a complex number times a complex number, and they both have the real part and the imaginary part. So you want to treat this just like if we were multiplying binomials where you have an x value. You want to FOIL it out. Okay, so we're going to say 3 times 5, it's 15. Then we're going to say 3 times negative 6i, that's negative 18i. 3i times 5, that's a positive 15i. And 3i times negative 6i. A positive 3i times a negative 6i, that's a negative 18i squared. Alright, so now we have like terms. These two I terms are like terms, so you want to put those together. And the I squared, right here, we always plug in a negative 1 for I squared. Okay, so let's see what that's going to give us. 15. Then add the two I terms together, so that's going to be a negative 3i. And then when I plug a negative 1 in for I squared, that's going to be negative 18 times negative 1. It's positive 18. Alright, so I don't want to leave my answer like that because I want to write the real number first. So I have a positive 15 plus 18. And so that's going to be 33. And then my imaginary part is negative 3i. Alright, so the answer for number 5 is B. Alright, number 6. 9 divided by 7 minus I. So we want to divide and express the result in standard form. So with imaginary numbers or complex numbers, if you divide like this, the way you do that is by multiplying by the complex conjugate. And the complex conjugate is going to be, you take what's in the denominator and just change the sign between the real and the imaginary parts. So you multiply the numerator and denominator by 7 plus I. Alright, and so when I do that, my numerator is going to become 9 times 7 plus I. My denominator is 7 minus I times 7 plus I. Alright, so let's multiply out the numerator. You get 63 plus 9I. Now let's multiply out the denominator. Alright, so you have 7 times 7, that's 49. 7 times I, that's plus 7I. Negative I times 7, that's minus 7I. And then negative I times positive I, that's negative I squared. Alright, these middle terms here, the positive 7i and the negative 7i, those cancel out. They're like terms, but they cancel out. That will always happen when you multiply conjugates. Complex conjugates or regular conjugates. The middle terms always cancel out. And then right here where I have an I squared, I want to plug in a negative 1. So I'm going to have minus negative 1. So it's going to be plus 1, right? So I have 63 plus 9i divided by 50. Okay, so this isn't my final answer because we always want to express imaginary numbers or complex numbers with the real part plus or minus the imaginary part. So we need to use term-wise division to break this up. So it's going to be 63 over 50. And you look at this sign right here, it's a plus. So plus 9i over 50, or 9 over 50 times I. The answer for number 6 is A. Alright, number 7. Solve the equation by factoring. X squared plus 2x minus 120 equals 0. Alright, so this is a trinomial. The way that you factor a trinomial is you make 2 sets of parentheses, and then if the trinomial has a 1 in front of the x squared term, which this one does, then the way you can factor it, you look at the factors of 120. There are a lot of factors of 120, but we want to use the factors of 120 such that when I add them together or I subtract them or whatever, I get a positive 2. Okay? Well, one set of factors that really jumps out is 12 and 10. Alright, now when I multiply them together, I want to get a negative 120 because there's a minus sign in front. And when I add the two numbers together, I want to get a positive 2. Alright, so you come down to your parentheses, put an x and an x. That'll give you x squared. And we know we're going to use 12 and 10. We also know that one of them has to be positive, one of them has to be negative because it's a negative 120. And so if we want a positive 2 here, we make this a plus, we make this a minus. Right, because positive 12 and negative 10 is a positive 2. Now this method only works if this is 1x squared. So don't think you can always use it, but when you have 1x squared you can. Alright, so now that we have this factored, we set it equal to 0, and we have the product of the two factors equals 0. Now you can apply the zero product principle. That says that I can set each factor equal to 0. So x plus 12 equals 0, x minus 10 equals 0. So you get x equals negative 12 and x equals positive 10. Alright, so number 7 is D. Number 8, same direction, solve by factoring. 11x squared minus 9x equals 0. Now, this isn't a trinomial because I don't have 3 terms, but it is a quadratic. I have an x squared here. What am I missing? I'm missing the constant term. So when you're missing the constant term, you just have the x squared and the x term. You can solve by factoring out the greatest common factor. So this has an x squared, this has an x. You have to bring out the smallest power of x. So I'm bringing out an x to the first. Then look at the coefficients, 11 and 9. I can't bring a number out of both of those. There's not something you can divide into 11 and divide into 9 evenly. So what would that leave me with? X times what is 11x squared? 11x. Minus x times what is 9x? 9. Okay. If you were to multiply the x back in, you would get what you started with. We don't want to do that because we're trying to solve. Alright, so now I have the product of these two factors equals 0. So I can apply the zero product principle again. So x equals 0. Well, that one's really easy to solve. And then 11x minus 9 equals 0. There's no work on the first one, so one of our answers is going to be x equals 0. The second one here, solve for x. So add 9 to both sides. 11x equals 9. Divide both sides by 11. So x equals 9/11. So our two answers are x equals 0 and x equals 9/11. And so that is C. Right, number 9, solve the equation by the square root property. We can solve equations by using the square root property if we're missing the x term, just the term that has an x. Like up here in our previous problem, the x term was the 9x, or the negative 9x. When you don't have that, you can solve by using the square root property if you have the other two numbers. Alright, so first get the x squared by itself. Divide both sides by 3. So I have x squared equals 7. Now take the square root of both sides. So I have x equals, now when you take the square root of both sides, remember you put a plus or minus in front of the constant. So plus or minus the square root of 7. So my two answers are a positive square root of 7 and a negative square root of 7. Alright, so that is B. B is in beta. Alright, number 10, solve the equation using the quadratic formula. Alright, quadratic formula is one of those formulas that a lot of times just sticks with you over the years, because a lot of times you're taught to maybe sing it or write it down until you remember it. But if you don't remember it, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, and so where do these a's, b's, and c's come from? A is the coefficient of the x squared term, so a equals 1. B is the coefficient of the x term, so b equals 7. And c is the constant, so c equals 7. Alright, so what I'm going to do now is just plug those numbers into my formula. So x equals negative b, so that's negative 7, plus or minus the square root of, b is 7, so that's 7 squared, minus 4 times 1 times 7, all over 2 times 1. Alright, so this is going to be negative 7 plus or minus the square root of 49, and now here I have negative 4 times positive 1 times positive 7. That's going to be negative 28 all over 2. So that's negative 7 plus or minus the square root. 49 minus 28 is 21 all over 2. Now, you want to see if you can simplify, and the way you can simplify something like this is if you can divide the same number into 2, negative 7, and what's in front of the radical, which is 1. If you could divide the same number in all three of those, you could simplify. You can see there's nothing in front of the square root, so that's my answer. Negative 7 plus the square root of 21 over 2, and negative 7 minus the square root of 21 over 2. All right, number 11, evaluate the function at the given value of the independent variable and simplify. So f of x equals negative 3x minus 8, and we want to find f of negative 2. So that means plug a negative 2 in everywhere where there's an x. Alright, so negative 3. Now, there's an x here beside the negative 3, so when you plug it in, you're multiplying. So negative 3 times negative 2, and minus 8. Negative 3 times negative 2 is positive 6, minus 8. 6 minus 8 is negative 2. So when I plug in a negative 2, I get out a negative 2. Number 11 is B. Number 12, f of x equals x squared minus 1. And we want to find f of x minus 2. Alright, so this means everywhere that there's an x in my function, I want to plug an x minus 2 in parentheses. Alright, I only have one x in my function, it's x squared. So where I have an x, I'm going to plug in an x minus 2, and then that power needs to stay there. Alright, so it's x minus 2 squared minus 1. Alright, so that's x minus 2 times x minus 2 minus 1. So fold that out. So it's x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And minus 1. Alright, so this is x squared minus 4x. And then, because those two are like terms, and then a positive 4 and a negative 1, this will give you a positive 3. So my final answer is x squared minus 4x plus 3. Number 12 is D. Number 13, the graph looks something like this. And we are asked to use the vertical line test to determine whether the graph is a function. So draw a vertical line. If it touches your graph, not the x or y axis, don't worry about that, just your graph. If it touches the graph one time, it's a function. If it touches more than one time, it's not a function. So when I draw a vertical line, this touches the graph one time, so this is a function. Alright, so the answer is B. Number 14. Identify the intervals where the function is changing as requested. Be a little more challenging for me to draw this graph because it increases and decreases and is constant, so make sure you refer back to the graph just in case mine doesn't quite look that great. I'll try to give it a go though. Alright. So, there. Try to get to 3. Up there and then on out. Okay, there's not an arrow on each end of the graph, but you can pretend that there is. And we want to know where this graph is increasing. That's what our directions say. So increasing means when is the graph going up from left to right? So you can see it's increasing from here to here. The way that we classify intervals on which a function is increasing, decreasing, or constant is by using x values. So you want to look at the smallest x value and you want to look at the largest x value. That'll give you your interval. Now your smallest x value is -2. Your largest x value is +2. Now this isn't an ordered pair, this is an interval. Alright? So -2 to +2, this is increasing. So the answer on number 14 is C. Number 15. Use the given conditions to write an equation for the line in the indicated form. Passing through 4, 3 and parallel to y equals 2x minus 6. And we want to write that in point slope form. Alright? So we're given a point and we're giving a line that our new line is parallel to. Since it's parallel, that means it's going to have the same slope as the given line. The slope of the given line is the number in front of the x, since it's already in slope-intercept form. So the slope for my new line is also going to be 2, +2. Parallel lines have the same slope. I need to put this in point slope form, so I need a point and I need the slope. Well, that's what I have here, point and the slope. Label your point as x sub 1, y sub 1, and then the formula is y minus y sub 1 equals m times x minus x sub 1. Alright, so y minus your y sub 1 is 3 equals m 2 times x minus x sub 1, and x sub 1 is 4. We were asked to put this in point slope form. So, are we done? Point slope, not slope intercept, so point slope, yes, we're done. Alright, the answer to number 15 is B. Number 16, passing through 5, 3 and perpendicular to y equals 2x plus 7. Perpendicular is very important for this problem. If a line is perpendicular to another line, that means that it has a slope that's the opposite reciprocal. So this given line has a slope of 2. So my line that's perpendicular to that, opposite means the opposite sign, so negative. The reciprocal of 2 is 1 over 2. So my new line is going to have a slope of negative 1/2. Number 16 asks me to put the equation in point slope form again. So the same formula. I have a point, I have the slope. So use the same formula that we used on the last problem, the point slope formula. So this is y minus y sub 1 is 3 equals m negative 1/2 times x minus x sub 1 is 5. And that's how we want to leave our answer, just like that. That's point slope form. Alright, so the answer for number 16 is B. Number 17, it says for the given functions f and g, find the indicated composition. So we're given f of x equals 3x plus 9, g of x equals 5x minus 1. Find f of g of x. Alright, so we take the second function and we plug it into the first function. So I'm going to take my g, this g of x here, and I'm going to plug it into my second function, or my other function, my f. I'm going to plug it in right there for x. If f would have had more than one x value, I'd plug it in for every one. Alright, I'd plug in 5x minus 1. It only has one x value, so plug 5x minus 1 in for x. So you have 3 times 5x minus 1 plus 9. Now, simplify this, so it's going to be 15x minus 3 plus 9. 15x, it's going to be plus 6. So the answer for number 17 is B, as in beta. Number 18 says, find the inverse of the one-to-one function. Here's the function, f of x equals negative 4x plus 5. We want to find the inverse. So to find the inverse, we follow 4 steps. The first step, instead of f of x equals negative 4x plus 5, we make it y equals negative 4x plus 5. The second step is to interchange x and y. So where you have a y, write an x. Where you have an x, write a y. So this is going to be x equals negative 4y plus 5. The third step is to solve for y. So get the y by itself. So I'm going to take and I'm going to move this plus 5 over. I'm going to say minus 5, minus 5. Let's see what that gives me. That's going to give me x minus 5 equals negative 4y. Alright, now solve for y. That means I need to divide everything by negative 4. You can just, since I divided each term by negative 4, but you can just divide this whole side by negative 4. That's probably better. Alright, so now I have solved for y. Y equals x minus 5 over negative 4. The fourth step, when you have y equals, is to write f inverse of x equals. So we're looking for x minus 5 over negative 4. So 18 is going to be B. X minus 5 over negative 4. Number 19, find the distance between the two pair of points. Here are my points, -1, 4, and -5, 7. And I want to find the distance between those 2 points. The formula for distance is distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Alright, so label all of your points. Label your first set of points x sub 1, y sub 1. Label your second set of points x sub 2, y sub 2. Now plug them in. Be careful if your x sub 1 or your y sub 1 is negative, because the formula does have a negative in front. So if you plug in a negative, then you're going to have minus a negative. Okay? So let's see what our distance is. It's going to be the square root of x sub 2 is -5 minus x sub 1 is -1 squared plus y sub 2 is 7 minus y sub 1 is 4 squared. Don't forget to leave the squares off. All right, that's very, very important. All right, so this is the square root of, anywhere you have minus a negative, put plus a positive. So this will be the square root of, that's -4 squared plus 3 squared, or the square root of 16 plus 9. So that's the square root of 25, and the square root of 25 is 5. So 19 is D. Number 20, find the midpoint. You have the point 7, 3 and the point 4, 1. Find the midpoint between the 2 points. The midpoint formula is x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. So it's an actual point. Alright, so label your points. First point x sub 1, y sub 1. The second point x sub 2, y sub 2. And let's see what we have. X sub 1 plus x sub 2, that's going to be 7 plus 4 divided by 2. And 3 plus 1 divided by 2. So it's going to be 11 over 2 and 4 over 2. So 11 over 2 and 2. So the answer for number 20 is A. All right, number 21, find the center and radius of the circle. All right, the general formula for a circle is x minus h squared plus y minus k squared equals r squared. So to find the center, it's going to be the point HK. There's a minus in front of both of those in the formula, so we need to take the opposite of -5 and the opposite of +7. The opposite of -5 is +5. The opposite of +7 is -7. So my center is 5, -7. The radius is r squared in the formula, so to find the radius you take the square root of the given number. The square root of 36 is 6. So the center is 5, -7, the radius is 6. That's C. All right, number 22, evaluate the expression without using a calculator. Log base 4 of 16. Our goal here is to get the base of the logarithm and the base of this number, 16, to be the same. If we can do that, then we can work out the logarithm. And we can. Log base 4 of 16 is the same thing as 4 to the second power. Now that these match up, the answer is the power. The answer is 2. Number 23. Log base 5 of 5. Well, they already match up. So the answer is the power. The answer is just 1. Alright, so the answer for number 23 is A. Number 24, solve the exponential equation. 2 to the x plus 8 power equals 5. To solve this equation, we need to figure out a way to move this power. And the way that we move this power is by taking the natural log of both sides. That enables us to move a power. So take the power and move it in front. Make sure you put it in parentheses when you move it. Now, distribute natural log of 2 to everything in the parentheses. So I have x times natural log of 2 plus 8 times natural log of 2 equals natural log of 5. Now get the x by itself. So subtract 8 natural log of 2 from both sides. So I have x times natural log of 2 equals natural log of 5 minus 8 times natural log of 2. Now divide both sides by natural log of 2. I don't know what that is, so it is time to go. But let me check that out for y'all. It's time to go, but the last problem, you can go too. I'm just going to finish this up. Alright, the last problem here, log base 5 of 3 plus log base 5 of x equals 1. You need to condense the left side first to solve. So since there's a plus, you can apply the product rule. So that's log base 5 of 3x equals 1. Now change this into exponential form. So 5 to the first power equals 3x. Solve for x by dividing by 3 on both sides. So x equals 5/3. That's B.